We're going to turn it over to our, thank you.
Thank you.
We're going to turn it over to tonight's speaker. Luckily, we were able to get in John Dobson this year. I think one of the, really going to stand out as one of the best speakers we've pulled to a banquet. John has been a pioneer in the amateur astronomy community. Who here doesn't know about the Dobsonian telescope now? I think that alone deserves a round of applause to John. He simplified it. John's ideas have also revolutionized the amateur astronomy community and caused a lot of people to talk. He's brought astronomy to many people, and he serves as a great to the amateur astronomy community.
That's what he does.
John promised he was going to send out his flyers tonight by throwing them, and I'd like all of you guys to get one of those flyers. And after John's done putting his flyers out, he's going to entertain us for the evening with some thoughts about sidewalk astronomy and his thoughts on cosmology. Maybe he'll even give us a little hint at why he invented the Dobsonian telescope now. Thanks a lot, and let's welcome John Dobson.
There's some more flyers here if I didn't get to all of you. There's a reason why they're called flyers. Now, I don't know whether you people want to ask me some questions. I'm interested in the whole universe, and you can ask anything you like. But he suggested that I say something about how the sidewalk astronomers got started, and that I say something about cosmology. But if you want to start off with some other questions, you have at it.
Did you know Timothy Leary?
But I do drop acid.
I'm proud of you.
When I got out of the monastery in 1967, I bought 50 kilos of vitamin C. And when I ran out, I bought another 50 kilos of vitamin C. And I take about the amount that other animals would take if they took it the way I take it. Everybody on this planet, except guinea pigs, fruit bats, and you guys, makes its own vitamin C. And they make 6 grams a day for our body weight. Watch it. And the amount of vitamin C that's destroyed in this country, pasteurizing the milk, is more vitamin C than is available from the entire citrus crop. Anyway, that's what I mean by dropping acid. I take about 8 grams a day. Anybody want to ask any more questions? Yeah.
What kind of suggestions do you have for telescope making, and why did you think of the idea of the Dobsonian telescope?
That's not an idea. It's the simplest way to aim above the horizon. And if there was an easier way to make a telescope, I probably would have thought of it. But I have to tell you one funny thing. The East Bay Astronomical Society, that's in Oakland, wanted to give me an award for public service in astronomy. So then somebody has to come and sweet talk you in front of the crowd. So somebody got the Dobsonian Revolution, the Dobsonian Revolution. I said all the previous revolutions were run with the cannons on Dobsonian mounts. There's no easier way to aim above the horizon than to go up and down this way and around this way. But what happened in the 60s was that the telescopes and the star parties, most of them were little telescopes, not big enough to show you the galaxies and things nicely, those deep fuzzies, distant fuzzy things we have, dark, dim fuzzies we call them. And so they were set up for photography. So they were 90% machinery and 10% optics. And we hit the fan with the 24-incher, which is 90% optics and 10% machinery. But we've hauled that 24-incher more than 80,000 miles in public service. We've been to a great many national parks. We've been to the Indian reservations. We've been over the Continental Divide. We've been up to Canada and down to Mexico with it. Anyway, more than 80,000 miles we've done with that. But with those bigger telescopes through the national parks and so forth, we're able to show people those distant things, you see, like those distant galaxies. But in order to give that kind of a presentation to people, you have to give a slideshow first. It is virtually hopeless to get the American public up to a telescope on a dim fuzzy and not tell them anything. It is hopeless. I was at the Lick Observatory one time, and I saw these elderly ladies coming down. They've looked through the 36-inch telescope on public night, and they're looking at the backlight pictures along the wall to find out something that looked like what they see. And they picked out a picture of the Milky Way. I thought, what the hell are they showing those ladies that looks like the Milky Way? So when I get up there, I see what they have. M13 is about this big, and they have the central region at 400 power. It's like small curd cottage cheese. And there's no information about it. They didn't know anything about what they had seen. What is the use of it? What's the use of it? But anyway, in the national parks where we see those dim things, we give slideshows first, you see. Then we flush them down the tubes. But in 1978, we were at the Riverside Telescope Makers meeting in Riverside on our way to the Grand Canyon. We do not spin our wheels for you astronomers. You can spin your own damn wheels. We spin our wheels for the public. They don't have wheels for seeing things in the sky. So we spin our wheels for them. So on the way to the Grand Canyon, we stopped at the Riverside Telescope Makers Conference. We had a 24-incher, a 22-incher, an 18-incher, a 16-incher, and some smaller stuff. And Federer Jr. had just abandoned the Sky and Telescope magazine, and DeChico and O'Meara had taken it over, and they were out there. And they looked through those telescopes and saw the clusters of galaxies in them, where are they? The clusters of galaxies in Hercules and stuff. Anyway, so they didn't know. I think they haven't seen those things like that. So right then and there, they asked me to write an article for Sky and Tel. So that was published in April of '80. It's called Have Telescopes Will Travel. Anyway, so I should tell you something about how the sidewalk astronomers started. Mrs. Sams called me up, Mrs. King Sams called me up, and she said that Brucey, that's Bruce Sams, nobody calls him Brucey anymore. He's big enough to splash me against the wall. But in those days, he was up to my nipples, and he was 9 years old, and he had a bigger telescope than any telescope in the San Francisco apertures. And he's taken the astronomy course at the Academy of Sciences in Golden Gate Park twice already. He's 9 years old, he's been through it twice already. And he's 5 years too young to join their club. They won't let him in until he's 14 and he's 9. And his mother called me up and says, Bruce, he needs somebody to talk to about astronomy and about telescopes. Anyway, he had made his telescope with me, you see it, 10.5 inches, about 7.5 feet long. Anyway, so that's how the sidewalk astronomers were started. I sent another kid over there, and they decided we should have a club. And there were 3 of us the first year, 13 the second year, 30 the third year, 60 the anyway, it was like that. Now we're all over the continent. We're even beyond, we've even got numbers on those flyers from Europe, you know. Anyway, but the sidewalk astronomers is a public service organization. We don't do anything else. We don't have meetings. We don't have banquets. We don't know nothing like this. We go out to the desert, you see, and we eat our cereal in a bowl. And then we rinse it out with milk and drink it. Then we rinse it out with water and drink it, and then we wipe it. We've had to do this for a long time in a lot of places. And usually a little after midnight, when the stuff public is supposed to go away, and we go in to go to bed, you see, then we have graham crackers and milk. Well, anyway, so the sidewalk astronomers do that kind of thing. And a few years ago, I was up in Seattle, Washington. Now, their astronomy club up there has had dark sky star parties, you know, for decades on end, you see, decades on end they've been doing this. And now, on the next week, when there's a quarter moon, they have a public star party in the old gasworks park. And they get several hundred people there looking through maybe a dozen telescopes. And they said to me, we do this because of you. Well, bravo for them. Now, you know, Erwin Schrödinger said, I don't like quantum mechanics. I'm sorry I had anything to do with it. But I don't feel that I am sorry that I had anything to do with the sidewalk astronomers. But I would never drive their 40-passenger school bus. I thought if the sidewalk astronomers depends upon me, I'd let it die. Unless there are other people willing to carry the telescopes to the public, I'm out of here. But anyway, we did that, and we still do it. I think that's enough. Do I need to know anything more about the sidewalk astronomers? Oh, yes, you do need to know some other things. We don't have money, you see. We make our telescopes out of ship's windows. I bought 4.5 tons of portal glass many years ago. I borrowed $1,000 from my mother. I bought 4.5 tons of portal glass. I hauled it away in the company's truck, and I put it in other people's garages. I didn't have any place to put it. Anyway, I thought I was going to have to sell it for little old ladies for stepping stones to their gardens. It never came to that. And one time when we were in Michigan, we were looking for some carborundum to grind one of those portals, you see, and we couldn't get 60-grit carborundum. And one of those carborundum dealers, he asked me, what are you going to do with it? I said, we're going to grind a portal for a telescope. Oh, he says it'll smash as soon as you start. Well, I said, we've done a few tons of it. We've done a few tons of them. Is that the water I had?
Yeah.
I have to tell you a story. I was at a restaurant in Texas 2 years ago with my friend. And the waiter asked me, what would you like to drink? I said, I'll settle for the oxide of the intergalactic gas in the liquid phase. And he turned to my friend, would you like some solids in yours? I knew I got some solids. Anything else you need to know about the sidewalk astronomy? You see, some of you guys who have telescopes out for the public who join the sidewalk astronomy and get on their newsletter. Now, we used to write newsletters. Hang on a moment. We used to write newsletters. And we decided that in our newsletters we would never mention anybody's name. The other clubs mention people's names. Sally did this and Peter did that. We'd never do that. We mentioned only the names of the telescopes and what we saw. Anyway, so we did newsletters for a long time. Anyway, what?
Rumor has it that at times you have slept in tubes of your telescopes. And when I heard that, I thought, my God, you must have been starving during these times. Were you hungry and without gas money at any time during?
I'm going to need somebody to translate that. My ears are 88 years old.
I've heard that at times that you slept in the tubes of your telescopes.
Oh yes, we sleep in the telescopes. Sure, we sleep in the telescopes. When the telescopes are still in the vehicles and we haven't set them up, we sleep in the telescopes. What the hell else will we have to sleep in? But there's a nice thing about sleeping in the telescopes. You can't fall out of bed. I've slept in 2 of them. I've slept in the one we call the little one. That's an 18-incher, 9 feet long. It sleeps only one person usually. The 24-incher sleeps 2 people in there. And one time there were 3 people in there, but one of them hadn't been born. Yeah.
Were you ever hungry or without gas money?
What?
Were you ever hungry or without gas money?
Well, it's not so much that, but the only reason we run is because people have helped us when we needed it desperately. One time going into Death Valley, I've been in Death Valley between Christmas and New Year's at least 13 times with the 24-incher and quite a number of times other times, and some once in spring with the 24-incher. Anyway, once when we were going into Death Valley, going over the last mountains into Death Valley, Brian Rhodes' Dodge van, hauling the 24, the engine completely broke down just before we got to the top of the mountain. So we transferred the 24 into somebody else's, ball back there. And I pushed his vehicle over the top, and he coasted 17 miles down to Stovepipe Wells. It's 4,000 feet downhill, and you coast the whole way. And then I had to haul him for 27 miles to the visitor center at Furnace Creek, And we had no way to get out of that difficulty. We tried all kinds of things, how to get out of this difficulty. And just at that time, the man who salvages the Arco stations in the desert showed up with his welding equipment. He went over to the junkyard, picked out all the pieces of metal that he needed, and built a tow bar on Brian's van, and built the whole back of mine with a trailer ball there. And I hauled him for 6,000 miles after that. But at the end of that day, one whole day with his welding equipment, he worked on that stuff to get us out of that desert. And I asked him at the end of the day, can we pay you something for this? He just laughed. He says, no, you may have to salvage me in the desert.
I would think so.
And I'll tell you another one. We were up in Canada, and I'm due to give a talk in the national parks on our side, and we're coming down from Canada in the rain. And we're going down a road where they have trenched the road. Right across the road, these got these trenches. They're this deep and this wide, and they're full of water, and you don't see them. They're full of mud and water, and you don't see them at all. Front wheels, boom, and all the radiators, all the fumes come out. Oh, Lord. So here we are in the rain, and we can't drive anywhere. And this great big American Indian, well, they don't quite have rangers. They have something like rangers. I one time asked a lady up there, you don't have rangers, do you? She says, no. We have naturalists to tell you what flower it is, and a warden to arrest you. Anyway, so this was a highway patrolman from Canada, and he got us down to the town. On Friday afternoon, after closing time, on a 3-day weekend, they're not open till Tuesday. I'm due in the United States on Tuesday, and it's Friday, and we're broken down. And what to do? One of my friends found a man who runs a gas station, and he has a truck that has a radiator in it. And he took his radiator out and put it in my vehicle for $30 Canadian dollars. That's why we did what we did. It's not our fault. Anything else I need to say? Yeah.
What is your favorite viewing site? Where do you like to view the stars from?
The best place that we've had the 24-incher for seeing conditions is Glacier Point in Yosemite, and it has been declared a day-use area. The baskets. It's been declared a day-use area, and they don't want us up there with a 24-incher for 2 or 3 weeks. So we haven't been there for 12 years. That 24-incher started telescopes in the national parks at Glacier Point long, long ago, about 71 or 72. It's been there for more than 100 nights in the course of 12 years. And the seeing conditions there are most extraordinary. It's dark enough so that you can see the zodiacal light coming up from both the east and the west in the night. And accidentally we saw the Gegenschein. Now, some of you probably don't know what the Gegenschein is. I'm going to have a detour here. The military has its uses. The military knows that from an impact site, something always leaves the impact site at a speed in excess of the impacting missile. Now that means, since the moon cannot be hit at less than escape velocity, it means that something always leaves the moon when the moon gets hit by an asteroid. So what leaves? So when the moon gets hit by an asteroid, you have an explosion of vaporized stone, which condenses to spherical glass beads. And some of them leave the moon and orbit the sun. So when you're looking down through your shadow, right down where your shadow would go through the solar system in the middle of the night, usually you're looking up this way, the sun is up there. But you're still looking down. You mustn't think that this is the only way that's down. When you look into the night sky, you need to persuade yourself that you're looking down. Otherwise, you will not notice how deep it is. Anyway, so when you're looking down through the solar system, you see the glass beads shining back at you, and it's right between where the east and west zodiacal lights would meet. You see this bright patch. We just noticed it accidentally. What the hell is that bright patch doing up there? And somebody figured out where the sun is. Anyway, so that's the best place that I've seen for seeing conditions. And up there, you see, we give slideshows first, and then we have maybe 300 people looking through the telescopes. We have several telescopes, not just the 24, we got an 18, several others. Anyway, so one time, a little boy up there at Glacier Point told me, he says, yours is the only program in the national parks that's not geared to a 9-year-old. I think he was 11. Anyway, ours are not geared to a 9-year-old. I'm going to tell you another funny story. We went to the Rocky Mountain National Park, and we were told that there are two places where we can get the telescopes out, at Hidden Valley or at a visitor center at 11,000 feet. And when we got there, we found that the place for our vehicles to be parked is right over an amphitheater where the rangers can give a talk in the evening. And we said, why can't we just get the telescopes out there? Oh, no, you might attract a crowd. Hidden Valley is locked away from the public. We'd be the only people in there. And the visitor center at 11,000 feet, there's nobody there after 6. So then we understood what's going on with the naturalists. He thought we were going to lick our chops and go to bed. Anyway, so we fled to the YMCA. We got 3,000 people a day there, 3,000 people a day there. And 2,000 people a day look through the sun telescope. We have a fail-safe sun telescope. Anyway, so 2,000 people do that. But so we pushed the naturalist, you see, and finally he said, there's a ranger going to give a talk at such and such a place on Wednesday night. After she's through, you can ask her if it's all right to set up the telescopes. So we took a 12-incher there and listened to what she had to say. As I recall, at least 8 out of 10 of her statements were wrong. Yeah. At least 8, I don't want to exaggerate, but at least 8 out of her 10 statements were wrong. And we waited and listened to all she had to say. And then I told her that the naturalist said I could ask her after she's through if it's okay to set up the telescope. And she said, they have no business to do this to me. I'm 19 years old. I've never studied astronomy for 5 minutes. They have no business to do this to me. Now these are your names. These are your rangers. You pay their salaries. They pee on the trees and they think their hearts belong to them. You pay their salaries. They don't pay yours. Anyway, so we let the people look through the telescopes. And she told us when she's to do this again. And the next time, she talked for 5 minutes and flushed them down the tubes. Anyway, you have to understand that just because the rangers know about squirrels, and they know about pine trees, and they know about some geology, doesn't mean they think there's anything going on up there. And if they think there's nothing going on up there, they think anybody can do it. It's really not like that. Anyway, I wish very much that the sidewalk astronomers could still do what we used to do, but at the Grand Canyon years ago, in 80, the ranger asked me to keep track of how many people use the equipment, and we were there for 3 weeks, and it was 20,000 people. And the next year, the naturalist sent me a letter. We don't need to be exposed to such controversial views in the national parks. He sent me the copy of that letter and asked us not to return. I stayed away for 14 years. But I answered his letter. I said, we don't, because he put all his pet peeves against the scientists into that letter against me. I said, we don't say those things. And you also don't say that the rocks at the floor of this valley, canyon, started at 4004 BC. He couldn't say that and be the chief naturalist in the Grand Canyon. Anyway, he didn't answer my answer to his letter. He didn't answer me. But I stayed away for 14 years. But just recently I was there again. And I thought, you know, it's a shame we can't still run through this place with our old 24 like we used to. And I thought, oh, Lordy, we don't have to do that anymore. There are 30 telescopes here now. Because somebody who looked through our telescopes way back then has started an annual star party at the Grand Canyon. But they do it only 1 week. I want 2 weeks. One without the moon and one with the moon. The American public is not allergic to the moon. The astronomers are allergic to the moon. Yes.
John, 2 years ago, Mara and I were at the Grand Canyon Star Party. Remember the slideshow talk he gave? and I got to meet Jane and Mojo, who I've known from the internet. It's quite a nice time.
Okay, good for you. Anyway, they get a lot of telescopes there, but I want it for 2 weeks. I think one of the difficulties is that the camping things go for 1 week, but they're going to have to extend it to us for 2 weeks, because we need to be there for 2 weeks. 1 week without the moon, so you can see those other things, and 1 week with the moon, so you can see those things.
Hey, John. Now I'm going to ask a question that I know some of us are wanting to hear tonight. Well, I read a quote that you said you were allergic to the Big Bang.
I'm allergic to the Big Bang.
Why are you allergic to the Big Bang?
Well, everybody should be. But let me tell you what I've just recently said. We used to say, it has yet to be shown how stupid a man could be. Then there was the Big Bang. You guys don't get it, do you? That's pretty funny. Well, all right, I'll tell you a little story. There was a king who came from a very distant place to his capital village and did not get a 21-gun salute. So he called the mayor. How come I came from a distant place to my capital city and I didn't get a 21-gun salute? He said, Your Majesty, there are 3 reasons. First, there are no guns. He said, never mind the other reasons. So I have several objections to the Big Bang. First, you can't get it out of nothing. Never mind my other objections. But you see, I was talking to some little tiny kids, and I said that the Big Bang people want us to believe that nothing made everything out of nothing. And this little kid gets up off the floor, you can't make anything out of nothing. Now you see, the people who invented the Big Bang had to have graduated from high school. No one who hasn't graduated from high school could possibly be stupid enough to think nothing made everything out of nothing. Now I apologize to the Big Bang people because they're really not stupid people. But somehow, and it is based on observation, you know, it's not based on something else. It's based on the fact that things are going away. But I have this problem. I don't think the universe has a rule that because you see something going away, it had to start where you are. I don't think the universe has any rule like that. So I have the stuff recycling from the border. I have a bang-free cosmology, you see. So I'm going to present that to you. Then I'm going to advertise it if I have time. And then I'm going to tell you what it predicts. So let's stick to the observations. What is it we see when we look way out there? We see that all the distant galaxies appear to be running away from us, and the farther away they are, the faster they appear to be running away from us, and it's in such a nice, steady progression that 15 billion light years away, they would be going away at the speed of light. Now, do any of you not know what redshifting means? If any of you don't know what redshifting means, put up your hand. Anybody? One hand is enough. One hand is enough. Redshifting is something that happens in radiation, and even if you don't know about that, you do know about fire engines. When a fire engine is coming toward you, the bell has a high pitch, and when it goes away, it has a lower pitch. Ding, 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 goes away at a lower pitch. Now, the reason that it slurs like that is because the fire engine missed you.
Well.
Anyway, so radiation does a similar thing. If something is coming toward you, the spectral lines of its radiation are shifted toward the blue end of the spectrum. That's the high energy end of the spectrum. And if it's going away, it's shifted toward the red end of the spectrum, the low energy end of the spectrum, and that's called redshifted. So what we see out there is that the faster away they go, faster they appear to be going away, the more redshifted they are. And the energy of the radiation goes to zero about 15 billion light years away. Now, when we look out there, we get this very low energy radiation coming in from way out there. Now, if the energy of the radiation is very low, the energy of the particles giving rise to that radiation is very low. Now, if the energy of the particles is low, the mass is particle. If the mass is low. If the energy is low, the mass is low. Remember, we found out from Einstein in 1905 that what we call matter is just potential energy. There's only one thing in this universe. I know they taught it to you at school, that matter can be converted to energy. That's not what the equation says, but that's what they taught you at school. That is cattle feces. It's not like that at all. That equation would be, if mass goes down, energy goes up, the sum of the two remains constant. Like in a swinging pendulum. This one goes down, that one goes up. This one goes down, that one goes up. And that's the way they taught it to me in 1934, and they've taught it to all of you the same way at the university. I know perfectly well what they do. Anyway, Einstein's equation says E is equal to m. What we call matter is just potential energy. So, if the energy of the particles is down, the mass of the particles is down. Now, there are two very interesting consequences. If way out there, as seen by us, the mass of the particles is very, very low, then all the radiation going through a field of low mass particles would get thermalized to 3 degrees Kelvin because the particles are too easily shaken, and the radiation gets picked up and re-radiated, picked up and re-radiated, picked up and re-radiated, and comes out thermalized at 3 degrees Kelvin. You don't have our permission. I guess he has our permission. Now the other interesting, the amount of background radiation that you get this way is what corresponds to what we measure. The amount predicted by the Big Bang is about 2 orders of magnitude more than that. We get about 1% of the background radiation predicted by the Big Bang, and we do get the amount predicted by this model. The other interesting thing is this. If the mass of the particles out there is low, the momentum is low. Momentum is how heavy you are multiplied by how fast you're going in some particular direction. And if you're not heavy at all, it don't make never mind what you're doing. So if the mass approaches zero, the momentum approaches zero. If the momentum approaches zero, our uncertainty in the momentum approaches zero also, because you can't have a big mistake about nothing. So if our uncertainty in the momentum approaches zero, then by Heisenberg's uncertainty principle, our uncertainty in where they are approaches totality, and they have to recycle back in. Now, the next question is, how do they come in? Do they come in on the train? No, they tunnel back in. So I have to tell you people something about these particles. A lot of you already know these things. You have to keep your feet on the floor and pretend I'm not talking. But if these particles are not things like dogs and chairs and cats and things like that. They're like dollars in the bank, and there's no this one and no that one. There are 4 ways to put 2 pennies down. Heads up, tails up, tails up. This one heads and that one heads. There are 4 ways to do it. But there are only 3 ways to put down 2 electrons. Spin up, spin down, and 1 each. There isn't any this one and that one. There are only 3 ways to do it. Anyway, so when an electron goes from one energy level in an atom to another energy level in an atom, it does not slide down. It disappears from this energy level, and it reappears in this energy level, and there isn't any in between. It's just like dollars in the bank. If somebody writes a check on a bank in Santa Barbara to a bank in Portland, Oregon, nobody goes down after the money. It disappears in Santa Barbara and reappears in Portland. You must have noticed. And there isn't any in between. So if the particles disappear out there and recycle in your soup, you're not in position to complain. So now there's this question. There's still 2 other questions. What drives the expansion? You might think that the Big Bang people have that all solved. No, they made it up. They don't have it solved at all. They invented the big explosion. It does not follow from their model. Their model follows from that. And that they made up out of whole cloth. They couldn't even find the cloth. Anyway, so I have a driving mechanism. If the energy of the radiation loses its energy, if the radiation loses its energy by redshifting because of the expansion, then it drives the expansion. Anyway, so now you need to know what are the observational evidences that this stuff is hydrogen. That includes the ones that make the oxygen. The number of atoms of hydrogen required to make 1 drop of water. That includes the hydrogen in the water and the hydrogen required to make the oxygen. The number of hydrogen atoms required to make 1 drop of water is equal to the number of drops of water in 1,000,000 cubic miles of ocean. In a patch of ocean 1 mile deep, and 1,000 miles that way, and 1,000 miles that way, there are as many drops in that water as there are protons in one drop. And we need only one a year in the Empire State Building. And the custodians are not going to stumble over it. So we have to look to a much bigger volume. So there's a quasar not very far away in the Virgo cluster that's close enough to us so that its ultraviolet radiation reaches us in the ultraviolet and can't get into the atmosphere. So the Hubble telescope's outdoors. We asked it to look. Please look at the ultraviolet radiation from 3C273 and see if there are any shadows in this radiation that indicate there are clouds of hydrogen between us and it. And there are. There are indications that there are 9 or 12 shadows in there that indicate clouds going away at different speeds. Clouds of hydrogen going away at different speeds make shadows in the rainbow. And if you're a whole flock of them, it's called the Lyman alpha forest. So there is a Lyman alpha forest on 3C273, and we get it from the Hubble telescope. Now, according to the Big Bang, there should not be any clouds of hydrogen in there. There's no way to put any hydrogen in there, and there's no way to have clouds of hydrogen hanging around in there for 15 million years without condensing into something we could see. But they are in there. And the Hubble telescope says that there's more hydrogen in those intergalactic voids than is necessary to make all the known galaxies. So there is evidence, you see, that this stuff is recycling from the border. Now I need to tell you what my model predicts, because if I don't tell you what it predicts, you won't have any way to find out that I'm nuts. So I have to tell you how you find out that I'm nuts. So I was asked one time by the lady who runs the pretzel farm. Do you all understand pretzel farm, where all those folded yogis are? You know how they are, all folded up. Well, anyway, she asked me to give a talk on frustration. I thought, how can anybody give a talk on frustration? But I did it anyway, and I had so much fun that I did it again in Hollywood a year later. And then I noticed something which I hadn't noticed before. So I'm going to very quickly go through the story on frustration. I said I was walking down through Griffith Park, down the road, and there was this little, in the winter, the rainy season, and there was a little stream of water coming down along beside me, and I was thinking that the poets say that it will be happy when it reaches the sea. But the poets are wrong, you know. It won't be happy when it reaches the sea. The sea is trying desperately to get to the center of the earth, and the rocks are in the way, and it gets frustrated. Brace yourselves, it's going to get worse. So the rocks get frustrated. The rocks are also frustrated because they're trying to fall into the center of the earth, and the iron is in the way. And the iron is trying to fall into the sun, and its inertia is in the way. It goes round and round at 18 miles a second, like the rest of us, you see. And so it gets frustrated. And the sun is trying to fall into the galaxy, and its inertia is in the way, and it gets frustrated. And the galaxy is trying to merge with all the rest of the matter in the observable universe, but the expansion is in the way, and it gets frustrated. And the expansion is trying to reduce the density of the universe, but the recycling is in the way, and it gets frustrated. Now, don't you see what fun it is? If the universe were not made of frustration, it couldn't go on like this. If the universe were not made of frustration, it could not go on like this. And if anybody could show that any of these things could succeed, every steady-state model would be dead. You have to predict something, you see, that they can test. The first thing Einstein did when he came up with his gravitation theory was to tell him the light should be bent around the sun. So Eddington did it in 1919, and damn it all, it is bent that way. You know what Einstein said? If it didn't get bent like that, he'd feel very sorry for the dear Lord. The theory is right. Well, anyway, now you can get on my case. Because you're not supposed to like all this. A lot of you bought into the Big Bang. A lot of you bought into the Big Bang. I don't need that.
That's the bank. She objects.
That's what?
They're emptying out that thing that's collecting all the stuff on the outskirts of the universe.
The recycling.
Just like
Anyway, you can get on my case. Come on. You're not supposed to accept all this.
How long have you been crazy?
What?
How long have you been crazy?
How long have I been crazy?
Yeah.
Oh, I don't know. I'm only 88.
oh my God.
Can you tell me your early days in astronomy, how you got interested in it, and
I
some
got
early?
born. What's your problem? How I got into astronomy?
Yeah.
I got born. Is there some other way? However, I didn't know about grinding my own glass till I was about 40 years old. I was already old by then. I've been old for a long time. But grinding my own glass, I didn't know about that earlier. And when I found out about that, I thought, my God, I had no idea that you could do that yourself. And so then, after we did a few of those, I bought 4.5 tons of porthole glass. So we made those things into telescopes too. Some of them, of course, are tools. Now, if any of you didn't get flyers, there's still plenty of flyers.
Joe, we'll take 2 more questions, and then we're going to wrap things. If you guys can keep them quick, I promise. Joe.
Your opinions on dark matter and dark energy.
Thank you. I have asked 3 astronomers in the last 25 years or so, when a cluster of stars is formed, what proportion of the stuff in the cloud makes it into the stars, and what proportion gets blown away? And the first 2 people that I asked, this is many years back, said they didn't have an immediate number on that, but they thought probably between 1 and 10% made it into the stars, and between 90 and 99% gets blown away. Now the last person that I asked was at Caltech, and he said 95% gets blown away, and in some cases more, and in some cases less. So you see, a galaxy is a cluster of stars. And what we would expect to happen is that most of the stuff in the cloud did not make it into the galaxy. It was blown away by the stellar wind. Now Vera Rubin weighed NGC 4565. The central bulge is like this, disk is as flat as a plate. And the way you weigh a galaxy is to take 2 stars right near the middle. One coming towards you blue shifted, one going away red shifted, and you know how fast they're going, and you know how much they're orbiting, because stuff outside has no effect on the orbit. So then you take 2 more stars, you weight all of that. 2 more stars, you weight all of that. She went right on out past where she sees any galaxy, and there's 10 times as more stuff way out there than there was in the galaxy itself. Now recently, because we have pictures of the Large Magellanic Cloud more than 100 years old, and we have modern pictures, by comparing them, we've discovered that our own galaxy is 6 times wider than we thought this way, 6 times wider than we thought this way, 6 times wider than we thought this way, and about 10 times heavier than we thought it was. Now if you spread 10 times as much stuff into 200 times as much volume, you're not about to see it. Now not only that, but we now know that about half of the neutron stars that we know about, that have a density of 100,000 battleships in a 1-pint jar and about 10 or 12 miles in diameter, most of them, or at least about half of them, have escape velocity from the galaxy, and they're going out into the hovering layer. And hang on, I'm not through yet.
Just start, Ted.
And so those things, and the neutron stars from the globular clusters and the neutron stars from the central bulge are probably all around are hovering there, and that's a lot of mass. Now that is not visible mass, and I think what's called dark matter is ordinary matter. Now the reason the problem has come up for the Big Bang is simply because they accepted, when Fred Hoyle pointed out in the 70s, that the helium abundance of the universe was not okay for the steady state models. They accepted it as their own. Now if there's all the rest of that matter out there, and if it's ordinary matter, the helium abundance is not all right for the Big Bang. So then, in order to cover that gap, they said, well, let the dark matter be spooky stuff that doesn't know anything about anything except gravity. So then why didn't it fall into the galaxies? Well, it can't fall at all without getting rid of its gravitational energy. But I think the dark matter is ordinary matter. But this fancy stuff, this spooky stuff, dark matter, that's a Big Bang problem, and this dark energy is a Big Bang problem, because according to the Big Bang model, all models have the expansion rate slowing down because gravity is pulling back on them. And now they find it is not slowing down.
Okay, so you got a question?
Do you believe in a creator that created all these things?
I don't believe in beliefs. I'm not a believer. I believe in sticking to the evidence, you see. But I understand that there has to be an exterior decorator. Now let me go back a ways, okay? There were some physicists a long time ago, and their word for the universe was Jagat, the changing. And they were smart enough to see that if the universe is changing, there has to be something against which it changes. That has to be not in time and not in space, not changing, not divided, not finite. Then their problem was, if what exists is changeless and we see it as changing, how the hell do we do that? They said it can only be by mistake. So they studied mistakes. Now they said, they have plenty of snakes there. They said, if you mistake a rope for a snake, there are 3 things you have to do. First, you have to fail to notice that it's a rope. That's called the veiling power. Then you have to jump to the conclusion that it's a snake. You do that on your own hooks. And then the third thing is you had to have seen jumping to the wrong conclusion, that's called the projecting power. And the veiling power is because you had to see the length and diameter of the rope, or you never would have thought it was the length and diameter of a snake. So then what they said is, the changeless has to show it through our physics, the infinite has to show it in the physics, and the undivided has to show in the physics. Inertia is the changeless showing through in the physics. The electrical energy of an electrical particle, which would go to 0 if and only if the size of the particle went to infinity, that's the infinitude showing through. And the gravitational energy, which would go to 0 if and only if the divided in the universe went to 0, that's the undivided showing through. So this was figured out by somebody a long time ago. There has to be, underneath what we see, something that's changeless, something that's infinite, something that's undivided, and something that has to show through. Now, if it didn't show through in our physics, this wouldn't have been interesting. But damn it all, it does show through in our physics, and nothing else shows through. Not only that, but nobody at Caltech has an answer for any of those things. Why are the particles electrical? Why the hell do they fall together? And why the hell do they go?
Thank you.
Okay, we'll take, who else has a question? Greg, we'll let you with the last question and make this quick so we can let these people clean up and go home.
We all know the universe is expanding. However, there are certain things that aren't expanding. Certain galaxies collide. We have a great attractor out there.
All right.
How's that explained?
You have to be careful about the notion that the universe is expanding. Do you mean that it's finite, or do you mean that it's getting bigger?
Just getting, things are
You can't get off that. You can't get off that easily. It means one of 2 things. It either means that the universe is getting bigger, or that the observable universe is finite. And what it actually means is the latter, that the observable universe is finite. It's going away with this, what we call expansion. The stuff's going away, and 15 billion light years away, it's going away at the speed of light. Now, if you double the expansion rate, they'd be going away at 7.5. Not 15 billion light years, 7.5 billion light years away. So the universe would be half as big this way, half as big this way, and half as big this way. If you were able to double the expansion rate, the size of the universe would come down to 1/8. You have to think what you're saying when you say that the universe is expanding. And that's what you're saying. Now, what was it you're asking?
Boy, I don't know.
I was afraid of that.
I'd like to let's give the speaker one last round. And for John coming to speak to us tonight, I'm going to give him a ASH shirt. Hopefully he can wear it around and showcase ASH. The one thing that I promised we'd do before the end of the night,
Rick has a good phrase that we all need to take heed to before we leave here. And I'm going to let him get up and tell us about it. And I think we need to figure out if we think that's right or not. Once we come to a consensus on this, we've argued this for, I think,
I'm not going to do
year.
this, Ted.
Come on, Rick. One time. Rick was in the Navy, and this is going to help us all with astronomy to figure out when the next clear night's going to be.
A red sun in the morning is a sailor's delight. A red sun at night is a sailor's warning.
Don't get it.
You think that's right, or is that
Backwards.
wrong?
Is it supposed to rhyme, though?
No, it's not supposed to rhyme. Everybody thinks that's supposed to rhyme. Just remember.
Take 10 more
Everyone will have to
milligrams.
think about that until next year's banquet. But let's give one last round of applause. I want to thank you guys for coming.
Everybody also thinks that the center of gravity of a spider web is at the center of the web.
Good.